Hello friends, this is my second video on asymptotes. In my previous video, I have discussed the definition of asymptotes and the method of finding asymptotes by limit form. In this video, I'm going to discuss another method of finding asymptotes of given algebraic curves. First, let us come to rules. Now first is parallel to coordinate axis means method to find asymptotes which are parallel to coordinate axis means x-axis and y-axis. First rule says that the vertical asymptotes or the asymptotes parallel to y-axis of an algebraic curve are obtained by equating to 0 the real linear factors in the coefficient of highest powers of y in the equation of given curve. Means to find the vertical asymptotes or the asymptotes parallel to y-axis, we just have to equate to 0 the real linear factors in the highest power of y. Real linear factors in coefficients of highest power of y. And in the same way, in order to find the horizontal asymptotes or asymptotes parallel to x-axis, we have to equate to 0 the real linear factors in the coefficients of highest power of x in the equation of given curve. Let us understand this rule by an example. Find the asymptote of the curve y is equal to 2 plus x minus x square upon x square minus 1 parallel to the coordinate axis. First, let us write given equation of curve in this form. Equation of curve or the curve can be rewritten as x square y minus 2 minus x plus x square is equal to 0. Okay, we can write our equation in this form. Okay, now here uh, highest power of x in this equation is x square, and we have to equate to 0 the real linear factors in coefficient of highest power of x. Okay, now first we find the horizontal asymptotes, and for this we have to equate to 0 the highest power of x in equation of given curve. Okay, now now the coefficient of the coefficient of highest power of x, highest power of x, that is x square. The coefficient of highest power of x, that is x square, here is y plus 1, is y plus 1. From this equation we can easily see x square y plus x square. Okay, the coefficient of highest power of x is x square. Now therefore, by definition, therefore asymptote parallel to x-axis is given by equating to 0 the coefficient of highest power of x. Y plus 1 is equal to 0. This is the asymptote parallel to x-axis. In the same way, now we check the coefficient of highest power of y. The coefficient of highest power of x, highest power of y, sorry. Now here highest power of y is y only. That is y. Now coefficient of y is x square minus 1. Therefore, asymptote parallel to y-axis is given by equating to 0. This x square minus 1 is equal to 0. That is on solving this we get x plus 1 is equal to 0 and x minus 1 is equal to 0. Means we have two asymptotes parallel to y-axis which are given by x minus 1 is equal to 0 and x plus 1 is equal to 0. This is how we have to find the asymptotes parallel to coordinate axis. Now we come to oblique asymptotes, means the asymptotes which are neither parallel to x-axis nor to y-axis. Okay, and for this we have this method. First of all, the equation of an algebraic curve of degree n is of the form. In this form, we can rearrange our equation in this form: a naught xn plus a1 xn minus 1 y up to an yn plus b naught xn minus 1 plus b1 xn minus 2 y up to bn minus 1 yn minus 1 and so on up to ax plus by plus c is equal to 0. Here it is a polynomial in xy of degree n. See here, degree is n, here n minus 1 plus 1, that is n, here yn, that is n. Same way, it is a polynomial of degree n minus 1. Degree is n minus 1, here degree is n minus 2 plus 1, that is n minus 1. And here it is n minus 1, so and so, up to degree 1. It is a polynomial of degree 1. Here 1, here 1. Okay. And degree 0 here. In this way, we can rewrite our given algebraic curve. Then the rule says to find oblique asymptotes, first put x is equal to 1 and y is equal to m in phi n xy, which is a polynomial in xy of degree n. This is phi n xy, this is phi n minus 1 xy, this is phi 1 xy. Okay, similarly we have to find phi n minus 1 m and phi n minus 2 m. First, in phi n xy we have to put y is equal to m and x is equal to 1. Same here, we have to find phi n minus 1 m and phi n minus 2 m. Then the roots of this equation phi n m equal to 0 will give us m. This is called m giving equation. On solving this, we get the values of m. Okay. Then in the third step, we have to find the value of c, which is given by this equation. C phi n dash m plus phi n minus 1 m is equal to 0, where condition is phi n dash m is not equal to 0. That is, m is non-repeating root of phi n m equal to 0. Okay, on solving this equation, I get the value of c. Then on substituting value of m and c in the equation, y is equal to mx plus c will give us the asymptote of the given curve. Here the note point is that if phi n dash m is equal to 0, if this is equal to 0 but phi n minus 1 m is not equal to 0. See here, if this is equal to 0 and this is not equal to 0, then we have an of the form some constant divided by 0. Therefore, in that case, we have no asymptote corresponding to the value m. This is non-zero, this is 0. On solving, we get some number divided by 0. Okay, in that case, there is no asymptote corresponding to that given value, corresponding to that value of m. Okay, now let us understand this concept of finding oblique asymptote by example. Find asymptotes of following curve. Curve is given to us 2y cube plus 3y square x minus 3yx square minus 2x cube minus 3x square plus 3y square plus x minus 3 is equal to 0. Okay. Now here highest degree is 3. This 3, 2 plus 1, this 3, this 3. Okay. Now we start with phi 3m. Here phi 3m. Phi 3m is obtained by putting x is equal to 1 and y is equal to m. Put x is equal to 1 and y is equal to m in phi 3xy. Means polynomial of degree 3. This up to this. Then phi 3m is equal to 2m cube plus 3m square minus 3m minus 2. Okay. Now differentiating with respect to x will give us phi 3 dash m, that is 3 to the 6 m square plus 6m minus 3. This phi 3 dash m. Now n minus 1, that is 2. Here n is 3. Phi 2m. Now it is a polynomial of, put x is equal to 1 and y is equal to m in phi 2x, means polynomial of degree 2. This. Then we have this minus 3x is 1 plus 3m square. Okay. Phi 3m, phi 3 dash m and phi 2m. Now first I have to find m, and my m giving equation is phi 3m is equal to 0. Now this is 2m cube plus 3m square minus 3m minus 2 is equal to 0. Now we have to find the roots of this 3-degree equation. We start putting m is equal to 1, minus 1, 0, 2, minus 2. That's how we have to find the roots of this equation. Okay. On substituting m is equal to 1, this equation is satisfied. 2 plus 3, that is 5, minus 3 minus 2, that is minus 5, will give us 0, that is m is equal to 1, satisfies this equation. Therefore, on dividing this equation by m minus 1, I get minus m minus 1 into 2m square plus 5m plus 2 is equal to 0. That means from here we get m is equal to 1 is one of the root. And now solving this quadratic equation by we have a method for solving this: ax square plus abx 2abx plus by square. If we have this kind of quadratic equation, then x is given by x is equal to minus b plus minus under root of b square minus 4ac upon 2a. For solving this quadratic equation, ax square plus bx plus c is equal to 0. Then values of x is given by x is equal to minus b plus minus under root b square minus 4ac upon 2a. Okay, on applying that quadratic equation method, we get roots are m is equal to 1 and minus 1 by 2 and minus 2. We have these three roots. Now we have to find the values of c corresponding to each one of these three values. Okay, now I have c giving equation. This is my c giving equation. Okay, now c giving equation is c giving equation is c phi 3 dash m plus phi 2m is equal to 0. Here on substituting value of phi 3 dash and phi 2m, I get c 6m square plus 6m minus 3 plus 3m square minus 3 is equal to 0. Okay, I get this equation. Now when m is equal to 1, we have three values for m. Now one by one we start substituting values of m in this equation in order to find the value of c. Now on substituting m is equal to 1, here I get c. This will be 6 plus 6, 12 minus 3, that is 9 plus 3 into 1, 3 minus 3, that is 0, is equal to 0, 0. And on solving, I get c is equal to 0. Okay. Therefore, for m is equal to 1, y is equal to mx plus c gives y is equal to m is 1, c is 0, gives y is equal to x. This is 1 oblique asymptote. Now in the same way, when I substitute m is equal to minus 1 by 2 in this equation, I get c into, this is 1 by 4, 6 by 4, this will be minus 3, same, this is 3 by 4, minus 3 is equal to 0, that is c, this is 3 by 2, minus 6 is equal to 12, 3, 9, this is 9 by 4, and on solving this I get c is equal to 9 by 4 into 2 upon minus 9, that is minus 1 by 2. Therefore, y is equal to mx plus c gives y is equal to m is minus 1 by 2 minus x by 2 and c is minus 1 by 2, that is 2y plus x plus 1 is equal to 0. This is second asymptote, oblique asymptote. Now in the same way, when m is equal to minus 2, this gives c into 2 2s are 4, 6, 24 plus 24 minus 12 minus 3 plus 12 minus 3 equal to 0, that is this is c into 9 plus 9 is equal to 0, that is c is equal to minus 1. Therefore, y is equal to mx plus c gives y is equal to minus 2x minus 1, that is y plus 2x plus 1 is equal to 0. Therefore, this 1, 2 and 3. Therefore, asymptotes are given by 1, 2 and 3. Okay. This is the way to find oblique asymptotes using this second method. Okay. Now let us consider another example. Now consider this example. Now equation of curve given to us is x4 minus y4 plus xy is equal to 0. Okay, highest degree here in this curve is 4. Therefore, we will start with phi 4m. Okay, now we have to put x is equal to 1 and y is equal to m. 4 degree polynomial is this only. Therefore, I get 1 minus m power 4 and phi 4 dash m. Differentiating this with respect to m, minus 4m cube. Then n minus 1 here is 3, phi 3m. No 3 degree equation, that means phi 3m is equal to 0. Okay. Now m giving equation. Now m giving equation is phi 4m is equal to 0. That is, this is equal to 0. That is 1 minus m power 4 is equal to 0. Now this can be written as 1 minus m square, 1 plus m square is equal to 0. Since we have a formula for a square minus b square is equal to a minus b into a plus b. Now on solving this will give complex roots. M square is equal to minus 1. Therefore, only this will give us real roots. Therefore, we have only two values of m, real values. M is equal to plus minus 1 are the only real roots, Okay. Now C giving equation is C phi 4 dash m plus phi 3m is equal to 0. Now phi 3m is 0. That means this is C minus 4m cube plus 0 is equal to 0. Now for m is equal to plus minus 1. M is equal to plus minus 1. C is 0 only. If I take m is 1 here or minus 1, C will come out to be 0 only. Therefore, y is equal to mx plus c gives y is equal to plus minus x. Okay. That is y plus minus x is equal to 0 are the asymptotes. Okay, this is the way to find asymptotes. Now we come to the case when we have parallel asymptotes. Okay, now if I have this condition, phi n dash m is equal to phi n minus 1 m is equal to 0. If both these are 0, then in that case my C giving equation will be of this form: c square by 2 phi n double dash m plus c dash phi n minus 1 m plus phi n minus 2 m is equal to 0 in this case. Okay, since we have considered the case when phi n dash m is not equal to 0. Now if it is 0 and this is also 0, then in that case C giving equation is this. This equation gives two values of C, say C1 and C2, corresponding to the value m. And in that case, we have a parallel asymptotes given by y is equal to mx plus C1 and y is equal to mx plus C2. This case arises when phi and m is equal to 0 has repeated roots. Okay, this is the case when this gave us two parallel asymptotes. Okay. Now in the same way, if we have second condition, this phi n double dash m and phi dash n minus 1 m is equal to phi n minus 2 m, these three are equal to 0, then in that case C giving equation is given by this, which is an equation in 3 degree, and so it will give three values. Okay, corresponding to one value of m, I have three values of C here. This is another case of parallel asymptotes. Okay, now come to the examples. Consider some examples. Find asymptotes of following curve. Curve is given to us like this. Now here we have 3 degree equation. Highest is 3 degree equation. This, 3 degree equation, then this is 2, this is 1, this is 0. Okay, now we start with phi 3m. Here I have phi 3m. Phi 3m is given by put x is equal to 1 and y is equal to m in phi 3xy. Okay, now phi 3m is given by substitute y as m here, m cube plus 4m square plus 4m. Okay, this equation will give us phi 3m. Then we have phi 2m. Phi 2m will be given by this 5m square plus 15m plus 10. Now phi 3 dash m. Differentiating this, I get 3m square plus 8m plus 4, and phi 2 dash m is given by 10m plus 15, phi 3 double dash m is given by 6m plus 8 from this, okay, and phi 1m is equal to degree 1, this is minus 2, okay, this is phi 3m, this is phi 2m, and this is phi 1m, okay. Now let us first find the value of m. Okay, now my m giving equation is phi 3m is equal to 0. Now m giving equation is phi 3m is equal to 0. That is phi 3m is m cube plus 4m square plus 4m is equal to 0. That is m square plus 4m plus 4 is equal to 0. This is equal to m plus 2 whole square is equal to 0. That is m is equal to 0 minus 2 means minus 2 is repeated here 2 times. So we have 3 values of m. M is 0, minus 2, minus 2. Now C giving equation. C phi 3 dash m plus phi 2m is equal to 0. That is C 3m square plus 8m plus 4 plus phi 2m is 5m square plus 10 is equal to 0. Okay. Now for m is equal to 0. Substitute m is equal to 0 in this equation. 0, 0, 4 plus 0, 0 plus 10 is equal to 0. This gives us c is equal to minus 10 by 4, that is minus 5 by 2. Therefore, y is equal to mx plus c gives y is equal to m is 0, so only 0 minus 5 by 2. Okay, that is 2y plus 5 is equal to 0. This is one asymptote corresponding to m is equal to 0. Now for m is equal to minus 2. Okay, now when I substitute m is equal to minus 2 here, I get c, this is minus 2 square 4, 12. This is minus 16 plus 4. Same here. This is 4, 20 minus 30 plus 10 is equal to 0. This is 0. This is 0. 20 plus 10 minus 30 is 0. That means this gives us identity. Okay, this is an identity. This is 0. This is 0. Okay, therefore we consider second degree equation to find C. Therefore, I consider this equation 1 by 2 c square phi 3 double dash m plus c phi 2 dash m plus phi 1 m is equal to 0. Okay, now we will find value of c from this equation. Okay, now substituting values, I get 1 by 2 c square, this is 6m plus 8 plus c 10m plus 15 minus 2 is equal to 0. Okay, simplifying this, I get c square, this is 3m plus 4 plus c 10m plus 15 minus 2 is equal to 0. Now I will substitute value for minus 2 here. Okay, now taking m to be minus 2 in this equation, I get this is c square minus 6 plus 4 is minus 2 plus c minus 20 plus 15, that is minus 5, minus 2 is equal to 0. That is 2c square plus 5c plus 2 is equal to 0. Okay, that means c is given by minus b plus minus b square minus 4ac upon 2a, that is 4. This is minus 5 plus minus 9, 3 by 4. That means minus 5 plus 3 minus 2 by 4 and minus 5 minus 3 minus 8 by 4. That is, we have two values, minus 1 by 2 and minus 2. Therefore, y is equal to mx plus c gives, substituting m is equal to minus 2 here, minus 2x, and take c to be minus 1 by 2. That is, this gives us 2y plus 2x, 4x multiplied by 2 plus 1 is equal to 0. This is one asymptote, and y is equal to m is minus 2 minus 2x, and now substitute c is equal to minus 2, and this gives us y plus 2x plus 2 is equal to 0. Okay, this is how we have to find the oblique asymptotes in case we have parallel asymptotes. Okay, that's for this video. Now in my next video I am going to discuss some special methods to find asymptotes. Okay, if you have any queries or any suggestions, please write to me in comment box. Thank you.